Okay, welcome back everyone. In this example problem, we're going to look at how to solve multiple object systems. So what that means is you have two or more objects that are connected to each other, and they typically will share the same acceleration, and our job is to figure that out. So for example, we're going to look at number 81, which is on page 136. Now there's a pretty nice free body diagram of all the forces, but I would suggest that you hold off looking at that until after we go through some things here. So this is a pulley system, and this is actually called an Atwood's pulley. So basically the way it works is there's a big pulley, and on one side there's a box of mass M1, and on the other side is a larger box of mass M2. And we can be given the masses of the boxes and all sorts of things, but typically what we want to figure out is what's the acceleration of the system. And the way that we want to solve multiple object systems is we want to draw a free body diagram of each one and try to figure out which way we think it's accelerating and then solve from there. Okay, so what I'm going to do is try to identify forces acting on each object individually. So for mass M1 on the left, we're going to have a tension going upwards, and we're going to have a force of gravity equal to M1G. And for this, we probably can guess that because it's a smaller block, and it's on the left side and M2 is a little bit bigger on the right, that it's probably going to accelerate upwards. That seems like it would make sense. So what that tells us is that the tension has to be larger than the force of gravity. Then for the second box, well, because it's heavier, it's probably going to accelerate down, and the forces acting on it is the force of gravity acting on mass 2, M2 times G. And then, kind of like in our lab, we're going to have a tension going up. And later on in Chem-Phys, junior, senior years, you learn that these tensions aren't exactly the same because you have to take into account what the pulley is doing. We're not really worrying about that now, we're just kind of approximating. So in that case, the string just goes over the pulley and the two tensions are exactly the same. Okay, so how do we set this up? Well, we have to write a second law equation for each one. So this means that the net force on object 1 is going to be equal to its mass times its acceleration. And another hint is that if we know which way we think it's accelerating, in this case upwards, let's make that the positive direction. So that when I put in the net force, I have tension, which is in the positive direction, and gravity, which is in the negative direction, and that's going to be equal to M1 times A. Now the reason that I'm taking off the 1 for the acceleration is that because the objects are connected, they will have the same acceleration. Okay, now let's look at the net force on object 2. Well, that's going to be equal to the mass of object 2 times its acceleration, and this way downwards seems to be positive. So that means M2G will be positive, and then tension will be negative, and that will give us M2 times A. Okay, so there's two equations with two unknowns, tension and acceleration. And if we want to figure out the acceleration, we can just solve for tension and plug into the other. So the easiest way to do that is just to rewrite the first one, and below that rewrite the second one just slightly. And you'll notice that they both contain tension, and if I just add the two equations together, tension will cancel out. So M2G minus M1G equals M1A plus M2A. And if I gather terms, I have M2 minus M1 times G is equal to M1 plus M2 times A, or the acceleration is equal to the difference of the masses divided by the sum of the masses times 9.8. And if we go ahead and plug in the numbers that we're given, we're told for this problem that M1 is 0.20 kilograms and M2 is 0.25 kilograms. So if I plug those in, I'm going to get 0.05 kilograms over 0.45 kilograms, all times 9.8 meters per second squared. Notice how kilograms will cancel out. And so that's going to give me an acceleration of, whoops, something happened, there we go, about 1.1 meters per second squared. Now, is this acceleration up or down? Well, we can't really say because we have two different objects that are moving in opposite directions. So it's best to say that the magnitude of the acceleration is 1.1, and then to figure out which way, we look at the diagram. So object 1 is moving up at 1.1 and object 2 is moving down at 1.1. And that's the positive direction for each of those objects because we picked it that way. Just a last note, if you guess incorrectly, let's say if we had said, oh, the lighter object is going to accelerate down. Well, what would happen is we would get a negative number for this acceleration, and we would get the right number, but it would have the opposite sign. And that would tell us that the acceleration is opposite what our guess was. And that's okay, you just need to change your final answer to reflect that. And that's pretty much it.